And now let's switch gears, and we have just seen this design contest as one of the examples which impact generative AI can have on EDA and chip design. Now I really look forward to looking into other perspectives there as well. We have a very interesting panel here today. It's a truly global panel with Hammond Pierce dialing in from Sydney. Hello. What time is it now in Sydney?
midnight.
Thank you for joining. And we have Jean-Christophe Glass from ARM dialing in from Austin, Texas.
Hi, everyone.
Hello.
Thanks for having me.
Yeah. And on the other hand, we have Hussam Amrouche from the Technical University of Munich with us. And then also from the business side, from Cadence, Rod Metcalf, located in the UK. So really excited about that. Before we go into more details, let's do a little round of introductions by just telling us your background shortly and what your personal role is in AI, in EDA and chip design. Let's start again with Hammond. You are most far away, so let's get started with you.
Thanks very much. So I'm a lecturer here at the University of New South Wales in Australia. I specialize, or my research specializes in hardware design and hardware cybersecurity, and in particular AI and how AI intersects with those two domains. So we've been exploring in our research group for the last few years now, actually, how GPT models and large language models intersect with what we perceive to be the future directions for EDA development.
Thank you. Let's continue with Jean-Christophe.
Right. I work in the productivity engineering group of ARM. So that means we develop tools, flows, methodologies such that our CPU, GPU, interconnect teams, for example, can focus on their part of the job and have the right tools to do that. Been doing that for 3 years. Prior to that, I had been doing GPU hardware design for 13 years. And since the beginning of the year, I've been tasked here in ARM with investigating, all right, this generative AI technology, what does it mean for us? What are the opportunities in terms of hardware design and verification, also in software development?
Mm-hmm. Thank you. Let's continue with Rod.
Thank you. So I'm responsible for the AI technology development at Cadence. So I'm the product manager for our AI products. So I work with both the Cadence R&D team on the development side and also customers explaining how to deploy and use the Cadence AI products.
Mm-hmm. Sam?
Thank you. I'm heading the AI processor design chair at the Technical University of Munich. From the name, we are dealing with designing chips to accelerate AI, but at the same time, we apply machine learning for reliability. So we are highly specialized for ML CAD. In fact, in 2019, I was one of the founders for the machine learning for CAD. And this is something where we apply machine learning for many areas in CAD, but this is a little bit different maybe from AI, generative AI.
Yeah, but we will look into many different perspectives of the topic. Yeah, my name is Rosa Markarian. I have worked in the digital technology industry, mainly building the bridge between engineering and sales. And now I'm a freelance consultant, trainer, host, and lecturer at university as well, but a different topic. So diving into ChatGPT and the AI revolution, this design contest that we have just seen, it's a good example how the potential power of generative AI can now become accessible to everyone, basically. But there was, of course, already machine learning before that. So let me help understand what is now actually different with generative AI. How can that literally bring chip design to the next level, and to what extent you already use it? Who would like to get started on this one?
I can start.
Yeah.
So machine learning has been around for many years, and machine learning always was good and still good in optimization. So we see the machine learning in analog design has been used intensively machine learning for physical design, but all those problems is more about the optimization side, how we can get decisions better than what we can do. With generative AI, and when it comes to those very large language models, it's something completely different. It's because it's mainly about language. So now we are able to accommodate what we use as designers to chat with each other, to make better code, or maybe to figure out bugs. Now, somehow an AI engine can do this chat with us. And that's actually interesting because we accumulated maybe tremendous amount of chats, language that happened in many years. And that's now we are harvesting that. So just imagine like a customer service where you used to chat with them for many years, and out of sudden you accumulated and encapsulated all this knowledge within an AI engine. This is very different from optimization problems.
Yeah, I agree. I think the optimization side is very interesting. The challenge from the EDA perspective is very much, before machine learning and other key technologies like that, we had to create a single product that would address every design in the world. EDA just has to work on everything. And that was really difficult to do. So the beauty of AI, and large language models are coming online now, is we're able to learn about the design that's being created and then customize the EDA tools based on that design. And that is quite revolutionary. The ability to learn through EDA is going to be very, very powerful. We already have some technology. Cadence have been developing the optimization-based AI for a while. We have some well-established products in that area. But generative AI, large language models, is another breakthrough that we can make good use of. I agree with you. The user interface, the be able to interact with the tools in a language-based way is a big breakthrough. But the ability to generate design data is also a key breakthrough. So there's a lot of work that's already been done, especially in the optimization area with AI. Cadence have invested in that for many years. But the generative AI stuff is also very new, and there's huge potential there for EDA in general. So I think it has its place.
Mm-hmm. Jean-Christophe, you collaborate with Cadence as well. So how do you see that? Which advantages can you already see and use?
Right. So I'm going to answer these questions from a different perspective, right? Since at ARM we develop and verify hardware IP. So a bit more cautious in that sense. And as an introduction to the topic, I like to share my perspective that we are still at the early stage of the innovation cycle. And I think it's important for everyone to be aware of that. And for those familiar with the Gartner hype cycle, we are now at what is called the peak of inflated expectations. So therefore, there is a lot of work to prove the benefits of generative AI for hardware development. The technology is highly inspirational and promising, but we must build credibility first by demonstrating the value. So to answer your question, there is certainly a lot of proof of concept work, a lot of research going on in the industry, but I'm not aware of any use in actual product development in the hardware world. And in fact, in the introductory slide, right, the 10x revolution of generative, I think there was a date of 2030, right? I hope it goes faster than that, but to put some perspective, like right now, we are still at the stage of doing proof of concept work.
Mm-hmm. Yeah, so that's where we are right now. Hammond, how do you see it? Where are we on the Gartner hype cycle? What's your view?
That's a great question. I think to answer this, it probably is going to build from the other answers as well. I think the really interesting thing approaching this from the academic side, where I'm coming in from the university, right? One of the key differentiators, I think, of this type of AI versus, say, the AI that's been used for optimization in the past is that tools like ChatGPT and large language models really drastically increase the accessibility of what it is that you're actually doing, right? So yes, on one hand, maybe all of the engineers become 10 times developers. But on the other hand, maybe they don't, and actually you're just enabling 10 times more people to be able to do the kinds of design tasks that previously would have been too difficult for them to be able to do. So it's not just about making, talented engineers more talented or more productive. It's actually also saying, you're a domain non-expert, but maybe now, because we have large language models to abstract away the complexities of EDA or other tasks in that area. Now, someone who is a non-expert can say, hey, I want to produce something with, say, an amber bus, relating it back to the contest. And they don't necessarily need any expertise with having done amber bus technologies before. So, where I see it in terms of the hype cycle, well, obviously the language models still have a ways to go and a ways to grow when it comes to their abilities to write and interact with EDA tools. But at the same time, if you compare what they can do now in languages like Python, I still think there's a lot of ways to grow in a very proven area for the language models for hardware.
Thank you. Yeah, so you touched upon what impact generative AI will have, especially on the people doing the work of chip design. And I find it very astonishing that in most industries, the discussion and the concern is more about, generative AI will reduce jobs. But in this industry here, it seems to be the other way around. There is a shortage of talent, and there is a projected shortfall actually of 67,000 technicians, computer scientists, and engineers only in the United States by 2030, according to the Semiconductor Industry Association. So how do you think generative AI can help close this gap? I would like to get started with Jean-Christophe on this one, because I felt like you have a very interesting view on that, how positive the industry sees that.
Right, thanks. So, well, I think Hamon's answer was actually interesting, because I see it a bit the other way around for me, I think this technology is gonna allow us engineers with the background in hardware design verification to do more of what we can do to augment our capabilities, which is going to help address this shortfall in the number of skilled people to deliver the products of tomorrow, right? But I'm still a bit skeptical about people without the right expertise, the right background, that thanks to this tool they will be able to design complex hardware such as CPU or GPU, and on my bus maybe that's relatively simple. But when it comes to designing these complex processors, right, it's not just about making a functional design, right? Let's assume for a second that I could ask GPT to generate, a CPU of decent complexity. It's not just about having the design functional. It's also about understanding the content that it's going to run on. It's about understanding the trade-offs to make between performance, area, power, and it will get there one day, hopefully, but I think right now it's more inspirational than a short-term thing. It's too remote to me to think that anyone could just come and design a CPU that is going to be of production quality.
So it seems like there will be more work that can be done by generative AI, but then there will also be special expertise needed to evaluate the outcome. Rod, what is your view on the topic? And you also shared with me in preparing this that there also have been already similar developments in the past that we can maybe learn from today as well.
Yeah, exactly. We have been through similar revolutions in the past, and I completely agree with the other comments that in the very long term, can anybody design a chip? Yeah, that would be great. If we can use generative AI to make it much more accessible, that's good for the industry. In the short term, that's very much a stretch goal. But in the short term, what I do believe is some of the more junior engineers coming into the industry can become much more productive by using generative AI and machine learning in general. For those of us who've been in the industry for a while, we learn a lot as time goes on. if you can have a machine to help a junior engineer with a good understanding of chip design become a lot more productive in complex designs, that is immediately beneficial. As you mentioned earlier, there aren't enough engineers around. So the new engineers coming into the industry, if they can do more work more productively, that's a benefit for AI straight away. And I get asked this question a lot, is like, oh, great, machines are going to take over. There's no need for engineers anymore. I simply don't buy into that. We went through this transition with RTL synthesis. I'm old enough that I know what it's like to create a schematic. That schematic generation process went away overnight when RTL synthesis became popular. Suddenly, through RTL synthesis, you can generate a few 100,000 gates in a few minutes. That was a revolution in its time. Do we have less engineers now because of RTL synthesis? No, we have 1,000 times more engineers, but they're all working on RTL. They're all being much more productive. So we're at this next inflection point with AI. We're going to be more productive. That's great. But nobody got fired over RTL design. And I really don't think that's going to happen with generative AI also. But there's one other benefit that I've sort of come to realize over time. And I think that LLMs in general can also help design quality. I mean, there's a lot of bad RTL out there that we write in a hurry. It's not really thought through, and it comes back to bite us eventually. Doesn't matter how good your verification plan is, some bugs go unnoticed. Now, if we can use LLM technology to improve the quality of the code too, and the quality of the verification, that's immediately beneficial. So I think there's some aspects of LLM as far as quality goes, as well as pure productivity and engineering resources.
Mm-hmm. Yeah, Hussam, sounds like great prospects for your students. Huh? They can.
Well, I mean, if the generative AI will increase the learning rate of the students, and we can go from a fresh PhD to an RTL expert designer, and now they can get their design in 1 year, I will be more than happy, but I don't think this is easy. So I think the biggest benefit of the generative AI and those language models, large language model, is really helping the already people who are already educated and they are already willing to learn to just increase the speed of their learning rate. Talking about the RTL's bugs and if the generative AI would help us to really hunt those bugs more efficiently, that's true, but at the same time, they might generate bugs that is very difficult for us even to hunt them. So we need that we be careful about where we trust it and where we don't trust it. And that might be even more difficult because they learn from unseen amount of data, and maybe they learn also, maybe they are very creative in creating very challenging bugs that we'll never be able to figure out. And that's, I think, very, very disruptive for our industry, because we talk about industry where we build chips in a very sensitive area. So we have it in cars, we have it in healthcare, and we don't want a chip where there is a bug that we never thought about and then can cause a problem at a certain point of time. So that's, I think, maybe scary a little bit.
Mm-hmm. Yeah, so let's dive a bit deeper into the verification process and specifically the verification costs. I mean, this is another big challenge in this industry, and the verification costs will increase more and more as chips get more and more complex. Just a few numbers to put around that. Industry estimates are that verification costs from 7 nanometer design average at round about $220 million, and for 3 nanometer, they will boom to $650 million. Jean-Christophe, we also talked about it, that for ARM, the verification costs also pose a massive challenge in the whole development. So what is your view? Can generative AI help reduce those costs, and to what extent? Or will it then also produce like new bugs that we haven't seen before, as Hussam just explained?
Yeah, absolutely. I mean, generally for IP development, verification is the biggest cost, right? So this is definitely an area of priority to understand how generative AI can help. Again, referring back to the previous questions, to allow them to do more, right? To augment what they can do. So definitely a lot of hope in that area, just because the complexity of every chip generation is rising. And an example is, we have more and more of variations of an IP of different configuration. You can have configuration parameters, and when you get more of these, so you have more variants to verify. So another interesting area here, another interesting challenge for generative AI, or maybe it's more of a machine learning problem. I don't know, but if everyone has some ideas, that would be really fantastic. Is how do we take advantage of that technology to verify these variants, configuration variants of an IP? That's one of the challenges, that would save a lot of effort and resources if we found a good solution.
Any ideas for that among our experts here?
Yeah, I'm going to go some. So I agree with that. Verification is definitely a big problem. We've already used some AI techniques, not necessarily large language models, but some AI techniques to start scheduling verification to get to the failures as quickly as possible. I think that was some very immediate benefits just to make the verification cycle more productive, but you still have to do the verification. There's some other ideas around which is going to be quite interesting is when you go from the high-level spec to the verification plan, that is at the moment a very manual task. You need to interpret the spec and then come up with a verification plan that's going to try to check that spec has been done. I think there's great potential for large language models helping with that process. It may not do it completely, but it might get 75% of the way there, and then you finish the verification plan manually. So there is some automation there that I think large language models may benefit from.
Yeah, just to add on to that answer, one of the interesting and new features that we're starting to see with language models, only very recently in the last few months, is not only their ability to comprehend, unstructured specifications or unstructured additional context of whatever it is you're working on, but also training models to be able to call external tools. This is what OpenAI calls plugins with ChatGPT, but essentially it's the ability, it's the same training methodology that they use to teach it to converse with this RLHF. But essentially what you're doing is you're training the model that it doesn't need to be the source of all truth itself, and it's actually capable of learning that it can call external programs as well. I think in the EDA space in particular, this is a really interesting concept because a lot of what EDA does is built on collections of tools. So again, it really comes around to this idea that we're going to be able to use the language models as a new type of interface whereby the designer is able to, assign high-level tasks, and the language model is able to decompose those into smaller sets of, verification planning and things like that, reading external context, and then potentially even being able to call some of the external tools for you to be able to complete some of those steps.
Mm-hmm. So we see a lot of potential in that area, and then every coin has kind of two sides. So I would like to now switch gears and go a bit more in others challenges regarding generative AI and chip design as well. First one coming to everyone's mind maybe is the topic intellectual property. So what is your view on that one?
I think this battle is already lost. So if you look to the ChatGPT, so they already learned from many available data where it was nobody gave them the right to do that in the first place. So there's many things it's very difficult. So, and I think unless like everyone, we go from globalization to everyone really train his own model in his own company because they want to protect. But then again, everyone needs to generate this tremendous amount of data. So without collective, efforts, it becomes very difficult. And I think this is where we will see maybe where industry group themselves and they work together and other group themselves, which is not good because at the end we need those models that everyone profit. And we talk about the learning rate and that's against the learning rate. But I think that would be always the key challenge, who owns this data at the end and who has the right to use those models and the way that the people who generate the data would like to use.
An interesting trade-off between collaboration and individualization.
Yeah, absolutely. This is a very tricky subject. And I agree in the public domain, the argument may be lost. In the commercial domain, it's going to be a big deal because where this design collateral gets created, there is an ownership question. And the legal community, not just in EDA, but generally has to come to terms with this. And we need to figure out how to measure ownership and then assign it appropriately. Because the idea that everybody's going to create their own models is just not scalable. That there has to be a base model there, which gives you the human interaction and all the rest of it. As an EDA industry, we will add to that model and add our own proprietary data. But if we're all going to build our own, 2 trillion property models, that's just not scalable. So the underlying model that contains some information that is in the public domain, we need to figure out what the legal parameters of that are. The data that we train on, of course, then we know where it came from, we know who owns it. But in the public domain, it's much more tricky.
Mm-hmm. Jean-Christophe, how do you see that from a business perspective?
Yeah, I mean, right now there is just no other choice that waiting for, the countries across the world to revisit their laws to clarify the ownership of the generative content, right? In the meantime, there is a lot of work we can do to prove the technology, but when it comes to actually using that in production and, and deliver products generated from that, we just have to wait and see, how this is all going to land. I expect it's going to be at least another year before we see, some clarity in the legal landscape across the world.
Mm-hmm. And what is your outlook, Hammond?
Yeah, I think it's broadly the same. This legal question is primarily a question for lawyers, I think, and politicians. I don't really think it's an engineering question at all. I think there's a certain amount of confidence that tools perhaps like GitHub Copilot have, where, they've said that, hey, this is a tool that you can use in industry and it'll write code for you and so on and so forth. But at the end of the day, I think this is still a question that is not going to be decided by engineers.
Okay, then let's switch into another topic that can actually be decided by academia. So when we look at generative AI, what impact does it actually have on education today and in the future? Maybe let's get started with Hussam just to...
Well, I think this goes again back to the original point about increasing the learning rate. So I think it's one fantastic tool where it can be used in teaching. So of course, that also comes with the challenges during the education, how we make sure we really evaluate students on their talents, on their understanding of the subject, not only on developing the output. So I think that would be interesting and lots of fun for both from teaching perspective and also from students' perspective. But I think it's at the end of the day, we need that we make the best use of it to increase the learning rate. And if we can teach students even more within the same amount of time and they comprehend the material in a much better way, I think that's at the end our ultimate goal.
Mm-hmm. And how is this already being done right now? Like what impact does it have already today? Like,
I think now it's a very gray area because we are just still kind of trial and error. It's even not very clear when even a student uses a ChatGPT to write the thesis. So where does it stand? Sometimes we just say, okay, if she acknowledge ChatGPT and cite ChatGPT, but that's actually, we are still at the learning phase for everyone. It's a very interesting phase. Maybe after 5 years, it becomes something like common sense and everyone, agree on it. But maybe we go back to this video on YouTube and we laugh like, okay, we had no idea how to deal with it at that moment.
Hammond, do your students use ChatGPT the whole day long? What do you do about it? And what do you think about the impact for the future?
Yeah, so there's kind of 3, I think, leading theories within the universities right now for dealing with ChatGPT, right? There's the pretend it doesn't exist and hide from it approach and ban your students from using it. There's the acknowledge that it exists and don't actually do anything, so sort of status quo. And then there's the embrace approach, which is to tell your students, hey, ChatGPT exists, it's a tool that you can use, and actually kind of encourage them to use it. And that's where I have gone in my own academic space. So I teach FPGAs and I teach languages like Verilog and VHDL. Yeah, we've brought ChatGPT right into the lessons. It's good right now because actually the tool is not perfect, so we can actually show them, hey, it's not actually super amazing at writing languages like Verilog and VHDL. But across the board, I think there's a real power in these language models for being something like a virtual teaching assistant, right? Like a student can say, I don't understand this particular line of RTL. What is it doing? Here's the broader assignment in which I'm working on. What's actually happening here? From a learning perspective, that makes it very, very valuable. From an examination perspective, it makes it really, really challenging because at the end of the day, we do want to know, we want to be able to assess our students' understanding, and ChatGPT does complicate that a little bit. But from a purely just academic standpoint, it's a great tool, and I'm really enthusiastic about using it in education.
And then if you now all have a teaching assistant, maybe it makes your job in teaching also even more exciting. Sounds like it could be.
If ChatGPT or those language models help us to make even more challenging exercises and tasks to challenge more the students, and maybe we should collaborate to train our own models to provide very challenging tasks.
Okay, then looking at the challenging design contest ahead of us, what would be your advice for the teams? What should they focus on to win this?
I think probably it's about the efficiency paradox. So if we look to the previous revolution, when it came from Industrial Revolution, at that time, the steam engine was invented and the total consumption of coal was keep increasing instead of decreasing. But how could it be when the efficiency, or when we have something very, very efficient, we don't gain out of it? And that could be now the same problem. When we invent something very efficient and we start to use it a lot, we start actually to produce problems, and those problems will eat all this efficiency gain that we got at the first place. So now, in the context, if they really rely a lot on the ChatGPT in their language model or whatever to design those designs, and then they put lots of manual effort to start to fix them because there was no enough thoughts early how they want to really talk to that model, then the efforts to fix those designs probably will compensate all the gain that they obtained. And that's one of the criteria that will be evaluated, how much manual work you have put at the end to fix the design. And maybe that's at the end does not really worth the effort.
Okay, good tips.
Yeah, I would agree with that. And what we're seeing is, today in the university world, when a student comes out of a engineering degree, they probably understand place and route, they understand synthesis, they understand the basic chip design flow. But in future, we're also going to train for this whole prompt engineering sort of topic, where you need to craft your prompt correctly to get the output. I completely agree with you. And maybe that's going to be part of education in future. I mean, I speak from personal experience. The quality of the prompt dictates the quality of the output. So either we get rid of the whole prompt thing and we figure out a different way to interact with LLMs, or people learn how to program LLMs through the prompt. And my advice for the contestants with the challenge is invest some effort learning how to use your prompt, because that will get you a long way in terms of quality material coming out of ChatGPT or whatever LLM is used. But more generally, people are probably going to need to be trained in that area.
Mm-hmm. What advice do we have from overseas for our contest participants?
Well, that sounds like a very fun contest. I cannot apply. No, but seriously, yeah, very fun. So I would just say to the participant, yeah, just enjoy it, have fun, and once you've built a good design with that technology, come and apply. Have a look at arm.com. I'd be happy to work with you as part of our engineering team.
That's a great offer. Amazing. Hammond, any last advice from you as well?
I think the main thing is that tools like ChatGPT and whatever other language model you use, they will very enthusiastically give you responses. Often the challenge is not so much how to use the language model, but it's how to tell whether or not what it's giving you is any good. From the point of view of this challenge, we've been very graciously given access to all of these verification IPs. I think the single most important part of this challenge is going to be coming to grips with the verification side of things so that then you can really rapidly iterate with the language models. That's when you'll be able to really gain the benefits of the speed at which the language model can write and edit code is going to be directly related to the speed at which you're able to verify what's coming out of it.
Okay, I hope all the contestants are now well prepared and this will be shared with all of them. Thank you everyone for joining, for sharing your insights. I learned a lot. I think we all learned a lot and very excited about the upcoming contest. Thank you.